Welcome to the Land and Property Diary. Now, today on InfoHub, we'll talk about critical mistakes that we make during construction. Whether you're building your own house or you're building apartments for sale or for lease, we're talking about damp roofing, which many times actually when ignored can cause problems, health problems and also dampness in the house. So let's talk to Joseph of Jumbo Chem, who'll give us more insights on what it takes to use the right materials for damp proofing. Come with me. Joseph, hi.
Hi, how are you doing?
Salama sana, habari yako?
Salama kabisa.
Sana hapa mnakazana kukazana.
Tuko tumejikaza. Karibu sana.
Asante sana.
Yeah.
Today I'm here because I wanted us to talk about damp proofing. A lot of people in construction don't see the need or don't take it seriously. So maybe you can tell us about damp proofing kidogo, tupe information.
Okay.
What is damp proofing and how is it different from waterproofing?
Okay. When it comes to damp proofing, what we mean is how do you prevent moisture from getting onto your floor? Like when you build your house, when you are casting the concrete and you have done the flooring, how will you make sure that that dampness which comes from the ground up by moisture does not come onto your floor space?
Okay.
Now, that is totally different from when you talk about waterproofing, because when you are talking about waterproofing, you are focusing on how do you prevent water from flowing. But dampness is different from water. It doesn't flow, but it's a kind of, it percolates, or by the process we call osmosis. It just comes up by osmosis and it gets into your floor. And you find that much of the time you will have a very cold floor, or if you are using a carpet, a floor carpet, you find that your carpet is damp and it starts to smell. Or even when you look at your walls of your house, you start seeing mold forming along the walls.
So what are some of the methods that are used to avoid dampness or to damp proof?
Okay. The first method that is used to minimize or block dampness from getting onto the floors is by using a damp proofing product. There are different types of damp proofing products that are laid at the time of doing the screed, before you cast the screed or you cast the concrete, or what's commonly known as koroga kwa mchengo. Number two, there is what we call chemical waterproofing. You can do a chemical waterproofing where you mix chemicals with cement, and you cast, when you cast the slab, you cast with that kind of mixture. So it minimizes or blocks water or moisture from percolating onto the floor.
Okay.
So those are some of the common products used. And unfortunately in this market, a number of players don't even use any of the products.
Yeah. Mbona watu wengi huwa watumii any damp proofing, they don't damp proof. Mbona?
Some of the people who have gone through construction, they have not been in school. They don't understand the science behind damp proofing. So with lack of knowledge, that goes into the construction side, where they don't see damp proof as an issue or damp proofing as a very key element in constructing a house.
Okay.
Number two, cutting costs. People want to cut costs. So when they're looking at where do I cut the costs, then using a damp proofing product which is not feasible, you cannot tell whether it was used or it was not used. So that is removed out of the budget. But that now, in the process of cutting costs, you are compromising the quality of the house you are building by, of course, failing to use essential products like damp proofing products.
Okay.
Yeah.
Tuingie kwa products. As zingine you find when you are on shortcuts or want to save on costs, they will use materials that are not good enough or meet the standards. What are some of these materials that are used that don't meet the standards?
The most common material used in this market is a black polythene. This black polythene is manufactured, I cannot say where. People collect a plastic, they go melt it, add a black pigment on it, and extrude it as a polythene.
This is what you use.
This is a product we manufacture here through our own processes, and it's a product we offer for damp proofing in this market. Yes.
Very light.
It's not supposed to be heavy.
Okay, right?
Heaviness is not a quality of performance. We are looking at dampness.
Okay.
And how can the product be effective in blocking moisture. It's not how heavy or how big
It
It is.
Mm.
Now, this product, we make it through what we call an extrusion process. So we make this process by extruding low density polyethylene with a closed cell system, meaning that when you make the foam, it is 100% closed cell, meaning that it doesn't allow any element of moisture to pass through it. Then to add the strength, we laminate it with a special filling. The outer part feels like there's a layer of a film which we add onto the foam that is already 100% moisture proof. And you make this adds the strength and also adds the additional layer of moisture proofing. So like here you have like two products combined together and both of them are moisture proof to make sure that the product is strong, can withstand handling on sites, but at the same time it will remain effective while in use.
Okay.
Yeah.
So at what point in construction then do you use the damp proof materials?
Okay.
Because as zingine utapata I already built my house, fundi hakuweka, and now I want it. And I'm going to demolish the house.
You need God there. When we do a construction, the first stage normally is called excavation. You remove the cotton soil or the layer of soil, and then you bring in what we call adico and you compact the ground. Then before you do the concrete or you do the what we call kukoroga in mchengo, before you do the kukoroga, you bring in first this product, you lay it on the compacted floor, lay it and you overlap at around 10 centimeter from one layer to another. After you do that, after you have laid the damp proofing foam on the ground, you put a PRC wire on top of this, a PRC wire, you lay it on top of this, and that PRC helps to hold the concrete together. Then now you do the concreting or una koroga sasa. Now when you do that, this prevents any moisture that may come from the ground up onto your floor.
Okay.
That's how it is done in construction.
So kama ishajengwa ole wako.
Kama ishajengwa is like you have already messed up the whole foundation of the building. So you will have a problem of coldness, you will have a problem of dampness, and if and from there maybe you will have to demolish that floor for you to get back to the process of preventing, because moisture, once it gets into the slab and once it gets into the walling, it's already inside. You cannot prevent it at that level.
Okay. Yeah. Even as we conclude, are there regulations, in construction that say you must damp proof, any building that you're constructing?
Yes, they are. If you look at our building code, it defines clearly the requirement that damp proofing must be done for each and every building. It is there in the building code, and if we look at the designs that come from architects, damp proofing is provided for in the design of any building or any structure that needs to be built. Now, the only challenge we have is that the enforcement of those requirements or the regulations. But it's a must that any building you build has to have damp proofing.
Okay.
Yeah.
Last thoughts, word of advice?
Word of advice is that when you want to build, please don't have a contractor or a fundi doing your house without you understanding what are the key elements that must be done in your house. Educate yourself, and some of these things, because they are not feasible, like damp proofing, you won't tell. If you go after they have done the floor, you won't tell whether your house damp proofing was placed or not. So be aware that you must be aware that there is a need for every building to be damp proof. And when you want to start building, when your building is on, kindly inspect and check.
Asante sana.
Thank you so much, and you're welcome.
Thank you for the insights.
Yeah, welcome.
Well, there you have it. One thing I have learned in construction, every step is vital. And many times we make really costly mistakes because of the people that we go to for advice. Please always consult an expert. Foundation is the structural component that supports a building, transferring its load to the ground. There are several types of foundations, but they all serve the same basic function, which is stability. The most common types are shallow foundations such as spread footing and slab on grade, and deep foundations including piles and drilled shafts. But even the best designed foundations can encounter issues If the ground they rest on is unstable, this can lead to a phenomenon known as building sinking or settlement. Settlement occurs when the soil beneath a foundation cannot support the weight of the structure. There are several reasons why this might happen. To help us explore key factors, we talk to engineer Howard Mai. Karibu sana. Maybe introduce yourself and tell us what you do.
My name is Engineer Howard Mai. I'm a registered and practicing civil engineer. But in my practice, I have a bias toward the area of construction materials, foundations, and geotechnical engineering. When someone says that they're a foundation engineer or a geotechnical engineer, many times what goes through people's minds is that this person builds foundations. Being a foundation engineer, you do not build foundations. That's the work of the contractor and the structural engineer. Foundation engineers study foundations to give an engineering opinion of how much the ground can carry per square millimeter and how the construction materials behave with the environment where the foundation is being set.
Of late, we've seen a lot of issues with buildings sinking. What do you think is a problem from a professional view?
There has been a myriad of problems, and some of them have been discussed publicly. Partly, it could start with how the foundations were designed, because normally the foundation of the building carries the weight of the whole building, and depending on how you design them, they can easily punch into the ground instead of being held by the ground. So the engineers are supposed to study that ground and then come up with a type of a foundation that instead of punching the ground is going to sit on the ground firmly without going down. Buildings have been sinking, perhaps either because the people who designed the foundations did not understand properly the properties of the ground where the foundations are being designed, or it could be inadequate design, so that instead of someone properly sizing the foundation, they size it slightly smaller. So instead of it sitting and carrying the building, it punches the ground. Or sometimes it could be because of saturation of the ground. When you designed, you put up your building under dry conditions, and then the place becomes saturated. But when you examine those other different reasons why buildings sink, you are supposed to analyze case by case, because each case will have a different reason why it has sunk. That's why for someone to authoritatively say this is the reason, they have to go back again and now study that foundation and get an explanation, something like a forensic, to get an explanation why this particular foundation sank.
And how does one select a foundation for the different projects they may have?
You must have someone who will study that ground, and studying the ground does not just involve visual inspection. You will be able to see visually. You'll be able to open the ground either by hand excavation and examine the soil profile. You can also drill specifically, not just drilling, but drilling for the study, for geotechnical studies. There is a big difference. When someone comes here to drill for water, they simply punch the ground, destroy everything, and just throw out the cuttings. But when you are drilling it for geotechnical study, you have to carefully drive in a barrel that will pick a sample, so that you have a chance to extract that sample, test it in a laboratory, analyze it, get someone who will be able to describe to you the exact, if it's a rock, the exact type of a rock, the conditions and the state of the rock, whether it has got fractures, whether it is weathered, so that someone is able to characterize that ground properly. Because that ground characterization is what then the designer will base on to correctly design the foundation. As I said, part of what you look out for when you are studying the foundation, you want to know how much the ground can carry per square millimeter. That is a parameter that the structural engineer will use to design, for instance, the type of the foundation and the size of the foundation, to ensure that it corresponds with the load that it will carry above it. When they excavate, there is something we call lateral earth pressure. The earth tends to move horizontally, same way, almost like the way water will flow if you try to remove a wall next to it. So if there is an excavation in the next building and the excavated phase is not properly supported, the building that is existing, the pressure that it exerts on the ground could make the ground to shift one direction, and it will cause massive catastrophic problems in the old building that was existing, which never had a problem. But because of activities in a neighboring plot, new problems arise. So all these things have to be analyzed and looked at by a professional who should be able to properly advise. If we're excavating, what do we do? What effort are we going to apply? How are we going to go about it? How do we program our excavation so that it doesn't affect the next building? How do we treat our new building to ensure that it's going to be stable and it's going to be safe for any other buildings in the neighborhood?
Selecting the appropriate foundation types for a construction project involves a systematic approach considering various factors such as soil conditions, load requirements, environmental factors, and project-specific constraints. And we have different types of foundations. We have shallow foundations, deep foundations. What is the difference, and where do they come in play?
Normally, it's a match between the load current and the capacity of the carrying capacity of the ground. So the load current it's coming from the design. The architect has figured out the height of the building, how many floors are going up. The engineer is able to work backwards and know what load is going to be carried. And then another engineer, the foundation engineer, will also be able to tell him the capacity of the ground to carry. Once you have studied and characterized the foundation, you are then able to take the next step of selecting the type of foundation, whether you're going for shallow foundation, as you said, or whether you're going for deep foundation.
Okay.
And this will depend on, for instance, if you studied the ground and you've realized that you've been drilling and you've gone up to 10, 20 meters, you're not able to get any firm ground. Firm ground in this case, I'm talking about, you're not able to find anything like either rock or very dense soil where you can base your foundation. And when I talk about rock or dense soil, you have to look at it together with the total weight of the building that's going to carry. We have some firm soil that is able to carry a building up to a certain number of floors, depending on the weight that it will be transmitting to the touching point of the foundation. There are also other types of foundations. For instance, if you're doing a wall, you could be able to do a strip foundation where the wall sits on a long strip, and then the wall just rests in the middle of it and transmits the load of the wall into a strip foundation. That's also a shallow foundation. We have rock anchor foundation, where you have your rock is very close to the surface, and you will apply too much effort to excavate to set up a pad. So instead of having to put too much resources in excavating, you could consider doing a rock anchor, where you drill into the rock and then anchor your foundation into the rock, and you will still be safe. But all those are foundations that happen within shallow depths. We also have raft or mat foundations, where it's like you're doing a foundation where it will enable the building to float on the soil. So instead of having a pad or a strip, you do multiple pads connected together to form like a raft or a mat, and then just place your building on top of it, so that you have a bigger surface area to transmit your load to the ground. And it helps you to fix other problems, like maybe differential settlement, where one side settles, the other one remains up, and then it introduces too much stresses in your building. In the case where the rock is too far and the weights are too much, it is advisable to do deep foundations. And deep foundations, traditionally, you will achieve them through piling. And piling means you're driving, just for purposes of understanding, you're driving something like a column deep inside the ground up to the point where it will touch either solid ground, or you can drive it in a manner that it also gets strength through friction. Now, that's where you find we either doing a driven piles, or we have the driven piles or the bored piles. Bored piles is where you're going to bore a hole up to solid ground, and then you cast your foundation. Driven piles is where you basically put your pile there, and you drive it down either by percussion or by a hammer, hydraulic hammer, until the point where it cannot go any further. We call it the point of the refusal point. And then from that point, you put a pile cap. You put your you begin your foundations from the pile cap going upwards.
There are obvious environmental factors, whether it's seismic activity or it's groundwater. How do you then incorporate this in the design and foundations of a structure?
You will find this foundation will work for this site. It is red soil. The next plot is red soil, but it could be waterlogged red soil. Or the next plot could be red soil, but with two other tall buildings abutting it. Each of those situations, those environmental issues, they will give you a different challenge.
Civil engineers play a crucial role in construction projects, ensuring the structures are safe, sustainable, and constructed efficiently. Here is an overview of their responsibilities and contributions throughout the various phases of a construction project.
You must get a competent professional who is able to first study and pick these parameters and interpret them in view of the type of materials you're using, and the type of design and the load that is being carried. All those things cannot be done by the rule of the thumb.
All right. Maybe a word of caution to contractors and, I don't know, maybe developers?
My caution is that let us respect professionals, let us make use of them. You can pay that extra coin, but the gains that you stand to make when you pay that extra coin are huge. You cannot compare to what you stand to lose when you not use professionals.
Very important insights, engineer. Asante sana for your time.
Thank you and karibu sana.
All right. Selecting the appropriate foundations for a construction project is vital for ensuring the stability and longevity of the structure. Here's a concise recap of the key considerations when planning and constructing foundations. Determine soil type, bearing capacity, and groundwater level. Calculate and plan for both static and dynamic loads. Assess climate, seismic activity, and local regulations. Choose between shallow and deep foundations based on soil and load analysis. The importance of a solid foundation cannot be overstated. Foundation serves as an anchor on which a structure sits, providing stability, durability, and support. Without a good foundation, buildings are vulnerable to shifting as well as collapsing, compromising on the safety and longevity of this construction. Thank you for joining us today. I have been your host, Naomi Mbuvi. Have a fantastic week.